Very good evening, guys. We are all set to start the session 3 of your Python programming journey. Can you please type yes if I'm clearly audible to you? Just type yes if I'm clearly audible. Okay, so first I'll brief you about, I'll summarize that what all things that we discussed in session 2, and then we'll move to session 3, right? So in session 2, first we saw that what are variables, why we need variables in programming. After that, we figured out how to take input from the user. Also, we saw that why we need to use eval function when we want user to input numbers. And then we saw simultaneous assignments and multiple assignments with the help of which we can ask user to input multiple values in a single line only. Okay, so this was about session 2, and I promise you today's session is also going to be very interesting where we'll discuss about numbers. Let me brief you about that and let me share my screen with you all people. Okay, so these all are the topics that we will be covering in this session. We'll talk about constants, we'll talk about the different types of numbers, then we'll solve the operators that will be working on these numbers, and then we'll see how we apply these operators to solve real life problems, right? Just have a look at this program. We have seen this program in the last session where we were computing the area of the circle where using the radius of the circle. Let me open up. And then we were able to compute the area of the circle for which the radius has been inputted by the user, right? Suppose I want to modify this program so that it also computes the perimeter of the circle and prints it. For that, I need to add something to this one. Let me add first the comment compute perimeter using radius. So I know to compute perimeter, I just need radius, and the formula for it is 2 pi r. So perimeter of circle is computed by the formula 2 pi r. I can write it over here 2 into pi. The value of pi is 3.14, right? And then multiplied by radius. This is the computed value of perimeter. And I need to store this value. So I'll again use some variable. Let's name it as perimeter only. So this computed value has been stored in the variable parameter. Now I need to print this. So let me print over here. I use the print statement. Print perimeter. Perimeter is also called circumference, right? Perimeter. So I printed this, right? Now if I run this, I will save this program. Control S. Now if I want to run this program, with this shell. Now the name of the program is area.py. So I'll write Python area.py. You see, it is asking me to enter the radius. Suppose I enter 15. It is giving me area is 706.5 and perimeter is 94.2, right? One thing to note here is I'm using the value of pi, which is 3.14, correct? So the value of pi here is, the value of pi that I'm using is 3.14. Suppose your teacher said that you don't have to use the value of pi. This 3.14 means the value of pi is accurate to 2 decimal places only. Your teacher wants your program to be more accurate, suppose up to 5 decimal places. So first let me check the value of pi accurate up to 5 decimal places. So we'll go to the browser and I'll type pi over here. You'll see The value of pi is this. This is accurate up to 11 decimal places. I want to use the value of pi, which is correct up to 5 decimal place, suppose. So it is 3.14159, right? So I can note the value to be used is 3.14159. This is the value of pi accurate up to 5 decimal places, and my teacher wanted my program to use this value of pi. So what I could do is I'll write down this value and get back to my editor. Now I have to replace this value 3.14 to 3.14159, right? This is the value. So I am 159. Again, I'm using pi also to compute the parameter. Here also I need to change 14159, this value, right? So I was using pi at two places in my program. So I made two modifications in my program, right? Now you just assume if this value has been used 100 times in your program, will you be making 100 modifications? No, because you are smart, you will be using find and replace thing. But I can tell you that using find and replace is also the wrong method. You cannot use find and replace to make 100 replacements in your program. The reason for that is it can have certain side effects like this. Suppose you were using the value of pi 100 times somewhere and there was some calculation like this. Right? You were using the value of pi 3.14 and there were certain calculation like this. And now if you wanted to replace 3.14, right? You wanted, suppose it was being used 100 at 100 places, this value of pi 3.14 was used at 100 places, right? And you were trying to replace it with the help of find and replace. What you will do, you will replace 3.14 with 3.14159. You can see it will be replacing the values of pi 3.1, which is 3.14, but it is also replacing, it is also making, it will also make if you simply blindly do it, replace all, it will also replace the value over here, which is 83.14. It will make the replacements here also, right? And this is going to be a side effect in your program. This will give you certain incorrect results. So you cannot blindly use find and replace to make replacements all the place value, to make replacements at all the places, right? So now what we should do. So thing is, if you were using suppose 3.14, this value, right? What I can do is instead of using this value, I can use a label for this value. So I create a new label, which is pi, and assign it a value 3.14. Now, instead of using value, I will be using this label, right? If I'm using the value of pi at 100 places, I will be using this label. Now, if my teacher suggests me to make the changes to improve the value of pi up to 5 decimal places, I just have to replace the value of this label, right? 3.14. And everywhere wherever I am using this label, the value of pi will be updated. I don't have to replace it at 100 places. I just have to replace the value of label, and wherever the label will be used, its value will be automatically updated, or Python program will use the automatically updated value. I hope you're getting this. So using this label made my life easier, right? Now the thing is, you see this statement. This statement contains certain labels. Area is also a label. Pi is also a label. Radius is also. This statement is using 3 labels. But radius is a variable, we know, because its value may vary throughout the program, right? Area is also a variable because its value may also vary depending on the radius, right? But the value of pi is always going to be a constant. The value of pi will never be going to be changed in your program, right? During the execution of the program. But seeing this statement, I cannot tell which one will be a variable and which one will be a constant. For that, we generally use a simple convention that whenever we are using constants in our program, we generally use the labels for them with all uppercase, right? Now I'll use this pi, value of pi, with all uppercases because it is not going to change. Now if I look at this statement, area equals to pi into radius. By just looking at this statement, I can tell which one is variable and which one is constant in this expression. So I can say area and radius are variables and pi is a constant by just looking at this, because we are following, this is a standard convention which we should follow while writing the program. Now see, if I'll run this program, it will give me the correct output. There is nothing will change. I'm giving 15, so it is giving me area and perimeter using the new value of pi, which is 3.14159. It is more accurate compared to the previous values, right? This is what you can see. So these types of variables whose name generally we represent in all upper cases are called named constants. So we just provided a name to our constant, that's why they are called named constants. I hope you got this. So this is a name constant, how we are going to use them, and I also told you why we need to use them, right? So representing the constant values with the help of labels, and all the labels should be in all uppercase so that you can distinguish between the variables and the constants in your program, right? Next, we move to the numbers. Generally, you see two types of numbers: the whole numbers like this, 1, 2, 3, 4, and the numbers with decimals in it. So it is 1.2, 2.34, 3.2112. These all are the numbers with decimals in it, right? In programming, these whole numbers are generally called integers. And these numbers with decimals are called floating point numbers. We call them floating point numbers because they have a floating decimal over there, and this decimal can float at any place in the number, right? So that's why we call them floating point numbers. Now, when we have numbers, we have different types of operators also. We can use these operators to perform some operations on these numbers. We have addition, we have multiplication, we have subtraction, division, modulus operator. So we'll look at them one by one, right? First, we have addition operator. We know how do we use addition operator. We use addition operator to add two numbers. Then we have subtraction. We also know that subtraction is used to subtract one number from another number, right? Then we have multiplication. Now you need to note one thing over here is these addition, this plus and minus, can be both binary and unary operators. When we say unary, it means it is going to have only one operand. And when I say binary, it means it is going to have two operands. Operands means the numbers on which they will be operating. Right? So I'll show you that. Let me open up the shell again. This is our Python shell. Now, if I write only -5 over here, see, I am using this minus symbol for negating this number. So here, this minus is a unary operator, right? I can also write +5. By default, numbers are represented when they have no sign. It means it's a positive number. So you see this +5, this plus and minus are representing the unary operators, unary minus and unary plus operator. But when I write 5 minus 4, this minus becomes the binary operators, the subtraction operator. Here, this minus is subtracting 4 from 5. So this plus and minus can be used as both binary and unary operators. And we also saw that multiplication, if I want to multiply 2 by 3, we are using this asterisk symbol for multiplying. So this asterisk is multiplication operator. It multiplies. I have provided an indent over there. I don't have to give space. So 2 multiplied by 3 gives me 6, right? So this is how we can use addition, subtraction, and multiplication operators. Now you will see some new type of operator which is called float division operator. First, let me tell you that how it is going to work. If you remember, if I want to divide 4 by 2, suppose I want to divide 2 by 4, what should be the result? It should be 0.5. So if I want to divide, the first number is numerator, the second operand is the denominator, and this slash symbol is the division symbol, right? So if I want to divide 2 by 4, I'll simply write 2 slash forward slash 4, and it will give me the result which is expected 0.4. Now you tell me what should be the result when I type 4 divided by 2. You must be expecting 2. See, but it is giving me 2.0 because this single slash is actually the float division, as you can see. So the answer is always going to be a floating point value, right? It will always, so if it is 2, it will give you 2.0. The answer of float division or means single slash is always going to be a floating point number, right? So that's why it is called float division. Now we move to integer division. If you look at integer division, you might have got the idea that why we are using integer division. Float division gives me results in float value. Integer division will always give me the results in integer value, right? Now if I type suppose 5 integer division 2, the natural answer will be 2.5. But when I am performing integer division, that means answer is going to be integer part. The fractional part, or the values after decimal will be ignored. So when I say 5 divided by 2, it gives me 2.5, right? But when I say 5 integer division 2, it will give me only 2. The fractional parts will be truncated or ignored, right? So if I say 2 divided by 4, integer division. So 2 integer division 4. So we saw when we actually perform 2 division 4, it gives me 0.5. But when I am doing integer division, it will give me 0, right? Because answer will be the actual division answer will be 0.5, and it will ignore the or truncate the fractional part or the values after decimal. So it will give me the value 0. I hope you have got the idea and the difference between float division and integer division, right? Next is exponentiation operator. The exponentiation operator is used to compute x to the power y. Suppose I want to compute 2 to the power 3. I'll write 2 double asterisk 3. This will compute 2 to the power 3 for me. So 2 to the power 3 is 2 into 2 into 2, which gives me 8. And if you apply exponentiation operator, you'll get the answer 8. I hope you're getting this. Similarly, the exponentiation operator can be applied on negative numbers also. So suppose I have minus 2.5 something. I want to compute its power 3. So I can simply write minus 2.5 to the power 3, suppose. So it will give me a exponentiation operator can be applied on negative numbers as well, right? Then comes the remainder operator or the modulo operator. It is also called modulus operator. It actually gives me the remainder. Suppose I'm giving two numbers here. Let me have 10 mod. This is represented by percent symbol. 10 mod 3. So it will divide 10 by 3, and whatever will be the remainder. So 3 3s are 9, and the remainder is 1. So it will give you 1. If I write suppose 15 mod 2. So 2 sevens are 14, and remainder is 1. So it will give you 1. So if I write suppose 15 mod 4. So 4 threes are 12, and remainder is 3. So it will give me remainder 3. This is what modulus operator do. It gives you the remainder when the divisor is divided by the dividend. Okay. So this was about remainder operator. Now we can see that we know that there is addition, there is subtraction, there is multiplication, there is division. But two new operators are there, which is like integer division and modulus operator. Now I'll show you these division operators can be easily achieved with the help of, so if I'm doing integer division, I can simply perform the float division and use this function integer, which is provided by Python. It will give me the same result. Let me show you. See, suppose I want to see uh, 10 integer division by 3, right? So if I want to see the result of this, it gives me 3. Now if I do 10 float division 3, it gives me this certain this value. And if I pass this value to integers, right, integer function, 10 divided by 3, it will give me the same value which I was getting by integer division. Right? So with the help of float division and using int function, I can actually have the same results which is given by the integer division operator. I hope you're getting this. Similarly, this modulus operator can be replicated using this formula a minus b into integer division of a and b. Let me help you in this case also. 15 mod 4 gives me 3, right? And if I write 15 minus 4 multiplied by integer value of 15 float division 3, sorry, it's the 4, right? You will see the answer is 3. So 15 mod 4 can be actually replicated with the help of this formula. So we have the formulas to generate the results for the integer division and the modulus operator. Now the question is, when these things can be simply achieved with the help of formula, why do we need the new operators, right? The answer to this is very simple, because these operators are very much used in computer science or in programming. When you will start your journey with programming, you will be developing softwares, you will see that, and you will be solving problems, then you will see that these operators are very frequently used and will be very useful for you, right? I'll take certain examples and will show you the power of these operators, right? So suppose I'm given some number 1 2 3, and I want to remove the last digit of this number, right? I want to remove the last digit of this given number, right? If I have a number 1 2 3, the result should be 1 2. Can you tell me how we are going to do this? How we can achieve this? Any mathematical expression into your mind? Suppose another example, I have number 453256, right? I want to remove the last digit. The output should be 45325. How we are going to do this? Can you tell me? Okay. Can you think of this division operator, integer division operator for this? Any idea? 453256 integer division by 10 will give you the number 45325. I can tell you this is not only applicable for 453256, it is applicable to any number. You take any number and you perform integer division by 10, you will see that its last digit is gone, it's removed, right? Let me help you by writing a program for this, right? Because we have this program, so I want user to enter the number. So first we'll prompt user enter number, right? Then we will remove the last digit and will print the result. So prompting user for entering number, we need to use eval input. Also provide the message, enter the number, and we'll store this value in some variable. So suppose it is num. Now we need to remove the last digit. How we can remove? We have seen it is num double slash and integer division 10. Integer division 10 will remove the last digit and give me the new number. I have to update my original number, so I write num equals to num integer division 10. So the result will be again back stored in my num variable only. So my num variable will be updated. Now I need to print the results. I'll print after removing last digit. So I need to print the number. Print now. I will run this program. I hope you're getting this. I've not done anything. I've taken input from the user. I have performed that integer division by 10 operation on my number, and then I'm printing that number, right? Let me save the program and try to run this. Name of the file is lastdigit.py. It's asking me to enter the number. Suppose I'm entering this 4 1 2 3 4 5 6. The output should be 1 2 3 4 5 after removing the last digit. See, after removing last digit, the number is 1 2 3 4 5. So we have seen that integer division has removed the last digit of my number, right? The logic is very simple. I hope you're getting this. Whenever you do, suppose this is number 1 2 3 and I'm dividing it by 10, right? So it will give me 12.3 answer. If you take another number 2 3 4 5, I divide it by 10, the answer is going to be 234.5, right? And when I do integer division, this part is ignored. And we have number in which last digit is not there. So now I'll give you a task, right? I want to remove the last 2 digits of any number. Can you do it? Just give your answers in the comment box. If you want to remove the last 2 digits of any number, you should be able to do it right now after telling you this logic. Okay, so we'll look into it whether you're able to do it or not. Let's move to next thing. So in previous case, we removed the last digit, right? Now what do I want is I just want the last digit of number. I don't want the whole number. The result should be the last digit. Can you tell me how we are going to do this? You might have got the idea. You can use modulus operator for this. So if any number is there, I perform modulus 10 on it, right? It will give me the last digit of that number. You want me to verify? Let me help you with this. See, I had the number. Before removing last digit, I need to fetch the last digit. So I'll write the logic. Fetch the last digit. And the logic is going to be num last digit, suppose it is last equals to, I'm storing it somewhere, num mod 10. So num mod 10 will give me the last digit, and that I'm storing in some variable last. And I need to print the last digit also before removing it. Print last digit is, I'm printing the variable last for it. Okay. Now if I run this program again, so what I've done is I have simply performed the modulus 10 operation on my num and stored that value in a variable last. And then I'm printing, I'm assuming that this is going to be last digit, and then I'm printing this value, right? Now if I run this program, I'll enter 1 2 3 4 5 6 7, suppose. Now 7 is my last digit, and after removing the last digit, the number should be 1 2 3 4 5 6. You'll see last digit is 7, and after removing last digit, the number is 1, 2, 3, 4, 5, 6. So you have got the logic, how you can fetch out the last digit of number, how you can cut out the last digit from a number, right? Now you tell me what we need to do when I want to fetch the last two digits of this number. I hope you get this. Yes, we are going to do it mod 100. Last is mod 100. If I'm doing last mod 100, it will fetch me the last two digits of the number, right? Let me save the program and run the program again. You see this? I'm number 1, 2, 3, 5, 6, 7 again. So last two digits are 6, 7. It will give me 6, 7, right? Okay. So I hope you have got this. How to fetch the last digits. It could be last digit, it could be last two digits, it could be last three digits, right? Using modulus operation. And if you want to remove digits, you can use simple integer division operation, right? Now let's get to another example. This is, you might get an idea. This is a regulator, right? Regulator of fan, suppose. You might have seen it in your homes. So this regulator has four marks, 0, 1, 2, 3. And when I moved it once, it start pointing to the location 1. When I moved it twice, it start pointing to location 2. When I moved it thrice, it start pointing to location number 3. And when I move it 4 times, it again gets back to 0, right? Now, can you tell me that after n steps where this pointer will point? So suppose I take an example. I want the answer after 336 movements. I have moved it 336 times. I've rotated 336 times. Where this pointer will be pointing to? If you can figure this out, if you think you have some idea, it will point to 0, 1, 2, 3. Where it will point to? You just go to the voting link, the description in the voting link. The voting link in the description. You just go there, click there, and you can submit your solution. I'm waiting for your solutions, right? After 336 turns, initially it is pointing to 0, and after 336 turns, rotations, where this pointer will be pointing to. You can submit your solutions. Just go through the vote description in the voting link in the description. You can go there. Okay, people are saying 0. After 336 turns, it will be pointing to 0. The voting link is there in the YouTube description. You can go there and submit your answer. Okay, everyone is saying 0. Everyone is saying 0. I hope this could be the answer. Okay. Someone is saying 2, 3. Fine. Hurry up, submit your answers fast. Submit your answers fast. Okay. So initially the pointer is pointing to 0, and I've made 336 rotations. Hurry up, submit your solutions. The voting link is there in the description. You can click on that and then submit your solutions. Okay, most of the people are saying it's 0. Some are saying it's 2. Some are saying it's 3, right? Let me verify. Let me verify what it will be. Okay. So let's get back to the solutions. See, you can use modulus operator for it, and when we use modulus operator, the answer actually will be, because after every 4 rotation it will be set to 0 again. See, when I move once it will be at first position, when I move twice it will be at 2, then on third turn it will be at third position, and on fourth position it will be reset to 0. So we need to perform the modulus operation by 4, and after every 4 rotation it will be 0, it will be pointing to 0, right? So in 336 turns it will move many times through 0, and when on the multiples of 4 it will be pointing to 0, and after that, suppose the lowest multiple before 336, right? It is going to be, if I divide this number by 4, it is going to be 4 is 32, right? It is going to be 2, sorry, 4 is 32, it is going to be 1 and the 6, then we have 4 for the 16, right? And the remainder is going to be 0. So let me verify. Here also 336 mod 4, it gives me 0. So this is the correct answer. 0 is the correct answer, because after 336 rotation, 336 is a multiple of 4, right? And on multiple of 4s, it is going to be at 0 position only. I hope you got this. So this is again one more application of this modulus operator. So we have seen, if we want to remove the last digit, we can use integer division operator. If we want to fetch the last digit, we can use modulus operator. We can, if we want to check after n steps where the regulator will be pointing to, this is also one real life problem, right? You can again use modulus operator. These are examples. You will find plenty of applications of these operators when you will be entering to programming world. You will be solving real-time problems, right? Now it's a simple quiz time. So what I want is, I have certain expressions. I just want to check your understanding, that whether you have understood these expressions or not. So let me see. The first expression is 42 float division 5. It is float division. The result is going to be 40 to 5 8 is a 40 and 5 4 is 20. So it is going to be 8.4, right? Then we have 42 integer division 5. So it will be 8.4, and we have to remove this. So it is going to give me 8 only. I hope you're getting this. Then we have 42 mod 5. So 5 8 is a 40, remainder is 2. So mod 5 will give me remainders operator. 42 mod 5 will give me 2. 40 mod 5, 5 8 is a 40, remainder is 0. So 40 mod 5 will give me answer 0. 1 mod 2. You need to guess 1 mod 2. So when I divide 1 by 2, it is not divisible. So it is smaller number, it is greater number, right? It is always going to be the smaller number. 1, right? When I'm dividing a number by 1, remainder is always going to be 0, because every number is divisible by 1. So 2 mod 1, 1 to the 2, it is also always going to be 0. So we will look at these two expressions like after just few minutes. Let me solve this. 5 to the power 2. It is 5 raised to the power 2. It is 5 into 5, which is 25, right? And for this, I need to use the Python shell. 5.1 raised to the power 2. It has to be something around 26 point something. Let me check. 5 raised to the power 2. And 5.1 raised to the power 2. It is something I think 26.009. So it is around 26.009 something. Right? So if your answers are matching these answers, then it's correct. You have understood the difference between float division, integer division, modulus, exponential operator. And these two expressions we will be discussing in next slides, right? But before that, you need to tell me Suppose I was given three numbers, num1, num2, and num3. And I want to compute average of these three numbers. So how do we do it? I perform simply the sum and divide the sum by 3, right? This is how we do it. Now I'm assuming this is an expression that num1 plus num2 plus num3 divided by 3. I assume that this will compute uh, the average of these three numbers, num1 and num2, num3. Now if the value of num1 is 1, num2 is also 1, and num3 is also 1, then the average should be actually 1.0. Right? This makes sense. If I'm computing the average of all ones, the average is going to be 1.0, right? Now let me write a program for this and let me see whether I'm getting the average 1.0 or not. Okay, so this could be my demo.py. Let me go to demo.py. Here I have num1 equals to num2 equals to, so this is again simultaneous assignment, num3 equals to 1, right? Now I need to compute average. So average, I compute it like average equals to num1 plus num2 plus num3 divided by 3. Now if I print the average, run this program, you see it is giving me average something which is 2.33, but the answer that we were expecting is the average should have been 1.0, because I'm finding the average of three ones, right? It should be 1.0, but it is giving me 2.33. Can you tell what went wrong actually? The thing that is wrong over here is this mathematical expression has more than one operators, right? So it has two addition and one division operation. So when your mathematical expression or any expression has more than two operators, then the operators are evaluated in order of their precedence, right? So here you can see this exponent, this division was performed first, 1 division 3. This was performed first, and it gave me answer, suppose 0.33 something. And then this 1 plus this addition was done, 1 plus 1 plus, then this thing happened. So we got the answer 2.33 something. Our intention was to do this summation first, right? And then perform this division. But because our expression contained more than one operators, so the operators with higher precedence were evaluated first. Now the question comes to my mind, how do I know that which operators have higher precedence? So here I'm showing you the precedence order of the different operators in Python, right? So first of all, we have this at the top. This is exponentiation operator. It is at the top. So whenever you have an expression with the more than two operators and one of them is exponentiation, so exponent operator will be evaluated first. Then we have this multiplication, division, and both the divisions, and this modulo operator. All these operators have precedence lower than exponent operator, but they have same precedence. Similarly, we have plus minus. The addition and subtraction has lower precedence than this multiplication and division, but they both have same precedence. Now question is, what will happen when I have these operators with same precedence in my statement? Like, I'll explain you with the help of an example, right? So suppose I have this example, 3 plus 4 into 4 plus 5 into 4 plus 3 minus 2 to the power 3, right? So what happens is, this is an expression, how computer will evaluate it. I'm telling you this. So using operator precedence. So this expression contains brackets. So what will happen? First of all, the brackets will be evaluated. The expression inside the brackets will be evaluated. So it contains 4 plus 3, it will give me 7. So the expression will becomes 3 plus 4 into 4 plus 5 into this, the result 7 is here. 7 minus 2 into 3. Now we start scanning, the computer starts scanning this expression again from the left to right and find the operator with the highest precedence. So here you can see the operator with the highest precedence is this exponent operator. This exponent operator has highest precedence, so will be evaluated first. So we'll compute 2 to the power 3, which is 8. This will result in 8, and my expression will become something like this. So this 8 will be, this is evaluated, and we have answer 8 over here. Now you see my expression has multiple operators, and it has addition, multiplication, and subtraction operator. So we see the highest precedence is with these multiplication operators, but we have two multiplication operators over here, right? So they both have same precedence. So which will be evaluated first? The one which is occurred at the left side. So we start scanning from the left, right? And the first multiplication from the left will be evaluated first. So the answer is going to be 4 into 4. This will result me in 16, right? Now this expression has addition. Now if I look at this expression, it has addition. I'll start scanning from left. The operator with highest precedence is this one. So this will be evaluated, and we have the answer like this. 5 into 7, 35. 3 plus 16 plus 35 minus 8 we have, right? Again, in this expression, we have two operators, two addition operator and one subtraction. Addition and subtraction have same precedence, right? Now the question is, which one will be evaluated first? Because all the operators have same precedence, the one from the left hand side that encountered first. So this addition will be 3 plus 16, 19 will happen first, right? Now we have one addition, one subtraction, same precedence. Which one will be evaluated? The one that is encountered first from the left. So this one is the first operator. So we have 19 plus 35. So we have 9 plus 5, 14, 3, 4, 5. We have 54 over here, right? Minus 8. And then when we have 19 plus 35, 54 minus 8, then we have only one operation. It will be done. We have answer 46 with us. I hope now you have got the idea how these operators are evaluated or executed when there are multiple operators present in your expression, right? So you don't have to remember this, like it's very simple. First is exponent, then integer division, then the multiplication and division and modulus operation. Then we have this addition and subtraction operation, right? Now we'll apply these operations. Now we'll apply this operator precedence rules and try to figure out the answer for this expression first. So we have 45 plus 4 into 4 minus 2. The operator with highest precedence is 4 into 4. So this will evaluate to 16. Then we have 45 plus 16 minus 2, right? So 45 plus 16 will be evaluated first. 45 plus 5, 6, 11, 4, 5, 6. It is going to be 61 minus 2. That is going to be 59, I think. I hope this matches your answer. So it is going to be 59. Now just have a look at this one. 45 plus 43 mod 5 into 3. So we have brackets here. So brackets will be evaluated first. The expression inside the brackets is also like it has multiple operators. So we know they both have same precedence. This multiplication and they have same precedence. The one at the left, right? This one will be evaluated first. So 23 into 3 will be 69. 69 mod 2, right? 69 mod 2 will give me 1 because it is an odd number. The odd number mod 2 is always going to be 1, right? So we have this multiplication by 1. So 45 plus 40, so it becomes like this: 45 plus 43 mod 5 multiplied by 1. So if I see, we have two operators with same precedence, right? Mod and multiplied. So mod will be performed first. So it is going to be 45 because they have same precedence. This occurs on the left hand side. 43 mod 5 will give me 3. Then we have 1. Then we will perform this first. 3 into 1 is going to be 3. 45 plus 3. Then we have 45 plus 3, that is 48. This will be answer of this expression. If you type this on your Python shell, you will get the same answer because Python will interpret it this way only. So now if you know the order of execution, how these operators are executed, then you will be able to write the expressions correctly, the mathematical expressions correctly in Python code. So that's why I'm teaching you all this. Now comes next thing, that is, you have you seen this type of thing? This is called Cartesian plane. It's just simple, like we have a floor. You can see a floor, and we have divided a floor in four parts with two lines, right? One is x-axis, horizontal axis, and another one is vertical, which is y-axis. So you can visualize this as your floor, which has been divided into four parts using two lines, and these two lines are passing through center. These two lines are meeting at certain point, which is called origin. This point actually. This will be the center of the floor of the room actually, right? Now, if I put certain object on your floor, right, and I want to assign some address to that object. So you have a room over here, right? I want to assign particular address to that objects on the room. What I can do is, let me try to explain this with the help of this Cartesian plane. So this is a Cartesian plane which has divided by two axes, x-axis and y-axis. Now, this is certain point where certain object is located, right? I give it a point, give it a name, suppose P. So to get the address, what I do, first I draw a line from this point to my x-axis, right? So I have two axes, x-axis and y-axis. So what I did is, I want the location, I want to assign an address to some point P, right? Suppose here certain object is placed on that floor, right? So I want to assign that particular address to that object, and where this object is located on the floor, right? So that address is generally assigned in terms of x coordinate and y coordinate. So when I say x coordinate, it means I'll draw a straight line from P point to x-axis, and wherever it cut the x-axis, that point is my x coordinate. Here you can see the straight line from P cuts the x-axis at 3. So the x coordinate becomes 3. Similarly, the straight line from P to y-axis cut it at 2. So the 2 becomes the y coordinate of this point P. So if I say point P has address 3, 2, it means I can identify where this point lies on the floor, right? If I'm talking about floor, I'm say 3, 2. So I will be able to visualize that where this would be. It would be 3 points, 3 unit distance from the x-axis and 2 units from the y-axis. So this object might lie somewhere here. And these addresses are unique to every point on the plane, right? Let's try for another point. Suppose we have point Q. Now, if I want to tell its address, if I want to figure out its address, this point Q, so I'll again drop a line from Q to x-axis. It meets at 1, so x coordinate is 1. Its y coordinate is 4. So the Q has address 1, 4, or we can say Q has address can be determined in terms of x coordinate and y coordinate. So Q has x coordinate 1 and y coordinate 4. Now suppose there are two objects lying on the floor and I want to compute the distance between those two objects, right? So I have got the addresses of these two objects on the floor. I want to compute the distance. So what I can do is I can connect them with a single line, right? And when the length of this line actually determines the distance between these 2 points. I hope this makes sense. So length of this line can be actually computed using this formula, x2 minus x1 square plus y2 minus y1 square and the whole square root. So this you might study in your mathematics, that there is a Cartesian plane. If we have 2 points P1 and P2 or P or Q, we can actually compute the distance between the 2 points using Euclidean distance formula. This formula is Euclidean distance formula, where x1, y1 are the coordinates of P, and x2, y2 are the coordinates of Q, right? So we have 2 points, P and Q, with coordinates x1 and y1, x2 and y2. If we have these points, we can actually compute the distance between these points using the formula x2 minus x1 square plus y2 minus y1 square and whole by square root. I hope you're getting this, right? Next thing is we need to write a program for the same. So we need to write a program to compute distance between 2 points, P1 and P2. P1 has coordinates x1, y1, P2 has coordinate x2, y2, and user should input the point coordinates in single line. So what do we need to make sure is we want user to input the x1, y1 in one line and x2, y2 in another line. So first thing that we are going to do is we are going to write, open the editor and write down the steps in the form of comments. Then we'll write the code. Okay. So I'll switch to editor. Let me create a new file over here. Name is suppose distance.py. I'll start writing the comments. First, I will prompt user to enter first point coordinates. Then I'll ask user to enter second point coordinates. Right? After we have first point coordinate, we have x1, y1 and x2, y2. Then we can simply use the formula to compute distance, right? Compute distance using Euclidean formula. And we need to print the distance, right? These are 4 steps that we need to do. And then now if I write the code, I want the user to input x1, y1 in single line. So again, we are going to use the eval input thing, eval input, and I'll ask user to enter points in this format, enter x1 comma y1. So by seeing this, user will come to know that I have to enter x1 and y1 separated by comma. Then I have to store these values in variables, suppose x1 comma y1. So because user will enter 2 values separated by comma, I need to have 2 variables on the left hand side separated by comma. Similarly, we will ask user to input second point coordinate. So we write x2, y2, new variables, and we will ask user to enter x2 comma y2. Right? Now user have entered x1, y1, x2, y2. We need to compute the distance. So we know the formula is x2 minus x1 square. Right? I can type it over here. So it was, let me, x2 minus x1 square plus y2 minus y1 square and square root of whole, right? So we know this square can be done with the help of raised to the power 2. So I can write x2 minus x1 raised to the power 2, right? Similarly, plus y2 minus y1 raised to the power 2. Can I write it this way? So let me do it. I write x2 minus x1 and whole raised to the power 2 is square plus y2 minus y1 whole raised to the power 2, x2 minus x1 square plus y2 minus y1 square. Now the thing is we need to compute the square root of this whole, right? So for square root, I know if I say square root of x, it is actually x to the power 1 by 2. I hope you have studied this in mathematics. If you have not, It is actually x square root is x to the power 1 by 2, or we can say x to the power 0.5, right? And this can be written in Python like x raised to the power 0.5. So if we need to compute the square root of whole expression, we can simply enclose this inside the parenthesis, right? I'll enclose whole expression inside the parenthesis, and I compute 0.5 power of this whole expression. That means whole ka square root. Now I need to store this the result of this expression in some variable. Let me name it as distance. Distance equals to this value. Now I need to print the distance. So print distance is our program is ready. We have implemented the Euclidean distance formula in our Python program, and we are ready to check. But before this, I want you to do one thing so that we can verify whether we have written the correct program or not. So suppose this is the coordinate, right? And suppose I take 1 point at my P1 is this 0, 0, and my P2 is here. It is going to be 4, 0, right? X is 4, y is 0, because if I draw a line from here to y, it is going to be meet at 0, right? And line to x will meet here only 4. So the P1 has 0, 0, P2 has 4, 0. Can you tell me the distance between these 2 points? What will be the distance? Just looking at this figure, can you tell me the distance? If you can, just go to the voting link description, right? Just go to the voting link in the description and you can vote your results here. The distance is going to be 2 units, 4 units, or 8 units. Distance between point 0, 0 and 4, 0. Just go to the voting link in the description. There you will see the question. Distance between point 0, 0 and 4, 0. 0, 0 is at origin, 4, 0 is at x-axis. So everyone says that it's going to be 4 units, and there are certain people who are saying it is 2 units, right? So we'll verify. Okay. So we have our answers. Most of the people say it's going to be 4 units. Some people say it's going to be 2 units. Let me try to resolve your doubts. See, the distance here is simply, if the points are in single line, we can simply calculate it by this. It is 1, 2, 3, and 4. It is going to be 4 units, right? So if the points lie in same line, I can simply calculate a single line. If the points are in same line, or either horizontal or vertical, I can simply calculate. Why I'm doing this is, actually, see, I have written certain program, right? I'll run it for 0040. But if I don't know what exact output is, how will I verify the output of my program, whether it's giving me correct value or not, right? So to verify whether the program I have written is correct or not, I should have certain test cases with fixed output with me. So this is our test case with fixed output, where we know if the point is 0, 0 and P2 is 4, 0, then the distance is going to be 4, 0 everywhere in the universe, right? This distance is not going to change anywhere. So our program should also follow this. If we have written correct program, our program should give the distance 4.0, right? Now let me try to run this program. Right, Python, then name of the file is distance.py. Enter x1, y1. So that x1 y1 was 0 comma 0. So I'm giving 0 comma 0. x2 y2 was 4 comma 0, right? See, the distance is 4.0. So we have correctly written the formula, Euclidean distance formula, because it is giving me the correct results for the test case that was fixed, right? Because everyone knows that the distance between 0, 0 and 40 is going to be 4.4 units. So it has given me 4 units. So there should be certain known test cases on which you can verify the functionality of your program. Now we can run it off for any value, right? x1, y1, suppose it is 23 comma 56, right? x2 y2 is suppose 78 comma 93. Now it is giving me certain distance. I can rely on this value that the distance between these 2 points will be 66.28 something, because this program has been correctly implemented. I hope you got this. So today we saw what different types of what are named constants, why we need named constants in a program. Then we saw, okay, first we saw the named constants, then we saw uh, why we need name constants in our program, then what are the different types of numbers we have integers, we have floating point numbers, then different types of operators that can be used with these numbers. So we saw we have addition, subtraction, multiplication, which are normal operators, but we saw float division, integer division, exponentiation, and modulus operator. Also, we get into details that why we need these two new operators when we have division operator with us. So what is the need of modulus operators? So we figured out the applications of these operators, and those were the real life applications. Those are only 3 applications. You will find more applications when you will be in working in this programming world, right? You will find these operators, the integer division and modulus operator, very helpful, right? And then we had the idea about the Cartesian plane, where we had a Euclidean distance formula, and with the help of this formula we computed the distance between 2 points. We learned, okay, so someone is asking to see the code. Let me share the code again. Here it is. You can verify whether your code is working correctly or not. So as I've told you, we are progressing forward. I hope you all are solving problems on the Geeks for Geeks portal. There will be a quiz and the practice problems that you can solve on the portal. If you have directly got the link from somewhere, you have not registered for this free course, right? You have this opportunity again. You can go to there is a link in the description. You can enroll in this course. And right now we just had only 3 sessions. So you can easily cope up with the things that you have uh, lost in the past, right? So it won't take you much time. It will be only 3 hours, 2 or 3 hours that you need to spend. Then you can again come on the same page. Okay. So let me stop sharing my screen. Now, if you have any queries while solving the problems on the portal, for that, there is a discussion form. There were some score related issues. We have solved those, right? And if you find any problem while submitting the solutions, submitting your code, you can post on those discussion forums. We are looking very actively on those, and we will be trying to solve your problems over there. This was for today. Tomorrow we will working on if statements, if else statements, right? And we will be, again, the lectures are going to be very interesting. And if you think that there are few friends of yours who does not find programming interesting, share this link with them, and let's see whether they try their hands on programming or not. I promise you, you will really find it very interesting, and you will uh, try to make a career in programming. We have this only I have only one motivation, that I want to motivate you to learn to love programming. Actually, this is only interest of mine. I want to develop your interest in programming. This is what I want. Okay, so we'll see you tomorrow with if else statements. What are if else statements? Why we need if else statements in programming? And what are different types of problems that can be solved? Okay, so keep solving problems on Geeks for Geeks portal, and we'll see you tomorrow, same time.